All right guys, here's the second video. It's going to be on lipids. We're kind of going to do the same thing we did with carbohydrates, but just take that information and take what's relevant to our lipids. So, first off, one of the things that is completely the same is the type of elements that are in lipids. So it's the same as carbohydrates. We have carbon, we have hydrogen, and we have oxygen. So once again, it's CHO. Here's the difference, because if you remember for carbohydrates, it was like C6, H12, O6. We had the same amount of carbon as we had oxygen, and then double that amount of hydrogen for carbohydrates. Here's the difference for lipids. We're going to have a large amount of carbon, so let's just say C20. We're going to have a larger amount of hydrogen. So right now, we're still maintaining that same pattern or ratio that we use for carbohydrates and lipids. But here's the difference. With the O, it might just be a 2. So the carbon and the oxygen are not going to match. We're going to have a lot more carbon compared to the amount of oxygen, unlike carbohydrates. So that's how you tell the difference between carbohydrates and lipids. But do remember that they both contain carbon, they both contain hydrogen, and they both contain oxygen. Okay, so let's go into the monomer, which is a fatty acid. Okay, so our monomer is called a fatty acid. Now, let's kind of apply this a little bit to what a fatty acid is. For a fatty acid, we're going to have a carboxyl group. So we're going to have our OH attached to a C, and there's our O. So again, this is a carboxyl group, and if you remember, a carboxyl group is the functional group that makes something acidic. It begins with a Ca. It's just the first 2 letters of acid reversed. So if you see carboxyl in something, you know it's going to be some type of acid. Moving on from here, we then have a very long hydrocarbon attached to this. I'm not going to make it real big, but there is our hydrocarbon. Okay, so this is our structure of a monomer of the fatty acid. So if you notice here, yes, we would have a large amount of carbon, we would have a large amount of hydrogen, but that's all the oxygen we're going to have. That's why 1 oxygen, 2 oxygen, that's why we got our 2 over there. All right, so that is the structure of our fatty acid, our monomer. Now, with the fatty acid, there's 2 different ones. This here, if you look, it's all single bonds there. This is a saturated fatty acid, okay? So we have saturated fatty acids. These ones are going to be mostly from animals, and they are going to be our solids at room temperature. So these are things like animal fat, the things you see on a steak. Now, if we took the same thing, drew it a little bit differently, put the hydrogens in just like we did in the past. This one, I have 1, 2, 3, so I can only have 1 to make 4. This one already has 4 bonds around it, so I can't do anything there. So there's our hydrocarbon once again, and let's attach our carboxyl to the end to make it a fatty acid. And there you go. This guy here, because of these double bonds, right here and here, as long as it has 1 double bond, it's going to be an unsaturated fatty acid. And what we mean by unsaturated is those double bonds make it a liquid at room temperature, and these are going to be things that are found in plants. All right, so that's your monomer. I'm done with that now. And again, guys, this is just a kind of a basic review. You should know all of your monomers by now and know that, okay, right off the bat, if I'm talking about a carbohydrate, I know it's a monosaccharide. If I'm talking about a lipid, I know we're talking about a fatty acid. When we get into the polymers, there's 4 of them. The first 2, which are steroids and waxes, that's all I really need you to know, is that steroids and waxes be able to identify that, hey, these are polymers of lipids, and also know that, obviously, These guys are going to be made up of our monomers, which are the fatty acids. The last two, phospholipids, we'll take a minute to go over that. Okay. Our phospholipids are going to be things that are found in the cell membrane. These make up the barrier from inside and outside of the cell. They look like this. Okay. The top area here, actually I'm going to make it two different colors just so you guys can see the difference there. There we go. The top area is a phosphate group. And it is hydrophilic, which means it's going to combine with water, it's going to like with water, it's going to get up close and personal to water. The bottom area here is our fatty acid tail. It's going to be mostly made of hydrogen and carbon, just like our structure of a lipid over there. And anytime it's a fatty acid, okay, think of fats. Fats really don't like water. Same thing with, waxes and stuff like that. You put a candle in water, it's not like it's going to soak up all that water. So they're going to be hydrophobic. Okay? So that's pretty much all I need you guys to know about the phospholipids. There's your structure of it. We got a phosphate up top, it's hydrophilic. We got a fatty acid tail coming down from it, it's hydrophobic. And then if we're talking about areas outside of the cell and inside of the cell, recall that the cell membrane is also called the phospholipid bilayer. Bilayer means two. So since that means two, that means we're going to have two phospholipids making up our cell membrane. And if we draw a short section here, it's going to look like that. And then our fatty acids on each one of them are going to be pointing towards the middle. Given this, we are going to have a phosphate touching the outside of the cell and a phosphate touching inside of the cell. Okay? And it could be reversed. I mean, if this is the bottom of the cell membrane, this would be inside, that would be outside. But regardless, the phosphates are touching outside of the cell and inside of the cell, which means they're probably touching water. All right? That's all I need you guys to know for your third polymer of lipids, which are phospholipids. One more. Our fourth one is our triglycerides. Okay. Composition. Our composition of our triglycerides is one glycerol attached to 3 fatty acids. So you can see it's a little bit bigger than our monomer. We have 3 of our fatty acids in there. What you need to be able to do is just diagnose what's going on with these triglycerides. So if this is the glycerol here, I'm not going to draw everything. All right? There's no reason to look at the glycerol. We don't need that. But what I am going to draw is our carbons. Okay? I have a chain of carbons here, which should be the fatty acids. I'm not even going to draw the hydrogens in because they're not important for us right now. All right? And then the last one. See that double bond there? If there is one double bond in a triglyceride, that's automatically the same thing as fatty acids going to make it unsaturated. Okay? So as long as there's one double bond, it's going to be unsaturated. Right? If we were to change this and make that a single bond, guess what? It's no longer unsaturated, and now it is considered saturated. 3 things to know about saturated. 1, if it's saturated, they're going to be solids at room temperature. They are going to only have single bonds between our carbons. And lastly, they're going to come from animals. All right? So that's pretty much what triglycerides, guys. What I need you to be able to do is if we have a very large triglyceride and it goes through a hydrolysis reaction, so we got a very, very big molecule of triglycerides, and it goes through hydrolysis, we're going to be breaking it down. So we're going to form individual fatty acids. And for that, whenever we're breaking it down, water is going to be needed. All right? Opposite, if we have a bunch of fatty acids and we put them together, it's going to be a condensation or dehydration reaction. And one of these 4 polymers could possibly be formed. All right? Real quick thing, guys, I know lipids were a little bit longer than the last one, but you know, that's pretty much all the need to know information. Hopefully this helped you guys out.